Okay, so in our third video, what we're going to do is problems 4 and 5. So let me kind of get situated here. And what we want to do, first of all, is for the problems we just did, for the function f, g, and h, I want to determine if they have inverses or not. So the first part of this review is, what kind of functions have inverses? Well, they have to be one-to-one. We already know their functions. 1x creates 1y, but to be one-to-one, 1y creates 1x. So it's a one-to-one relationship. So functionally, every x creates 1y. A one-to-one function reverses that. 1y has 1x. So if we go back and look at our functions from the last couple of examples, right, this function is not one-to-one, right? It passes the vertical line test, right? 1x creates 1y. But it fails the horizontal line test because 1y doesn't have 1x. As a matter of fact, we saw that in the last one, right? When y is equal to 0, there were 3 x's. When y was equal to -2, there were 2 x's. So that's not a one-to-one function. So we're not going to worry about an inverse for the function g. For the function p, we also have a problem because notice that the output of -2 has 2 pieces of input. All right, so this is no longer a one-to-one function. If we were to graph these ordered pairs, it would pass the vertical line test making a function, but fail the horizontal line test. All right, and then last but not least, for the function f, right, I know I got the graph kind of wrong, but it does pass the vertical line test, and it passes the horizontal line test, meaning every x has 1y, and every y has 1x. As a matter of fact, we even kind of saw that when we solved a couple of these equations. When x was 0, right, we got one value of x. When y was -3, we only got one value for x. So this behaves like a one-to-one function. So the only function that has an inverse then is f of x equals the square root of x plus 4 minus 3, right? And again, its domain was from -4 to infinity, and its range was from -3 to infinity, as we saw earlier. So how do we find that? Well, the idea is replace the f of x with y, and then we start creating the inverse by replacing or reversing the roles of x and y, because that's essentially what happens with an inverse function. It flip-flops roles. So this becomes x square root of y plus 4 minus 3. We want our inverse function to be a function of x. Right now it's a function of y. So we basically have to use our algebra and solve for y. So I'll add 3 to both sides. This gives us x plus 3 equals the square root of x plus 4. Square both sides. We get x plus 3 squared equals y plus 4. And if we subtract 4, we get y equals x plus 3 squared minus 4. Okay, now we have to be careful here, right, because a lot of you know that this is a parabola, right, and a parabola, if we were to graph it, right, is not a one-to-one function, and this is where this comes into play, right, because we flip-flop the roles of x and y's in an inverse function, we flip-flop the roles of the domain and range. So this would be the inverse function as long as the domain matches the range of -3 to infinity. So there would be our answer. All right, I think as a matter of fact, we would even use f of -1, right? So that's how we signify the inverse. That would be the inverse function for that function. So a lot of review there, what it means to be one-to-one, how to find an inverse function, and then having a restricted domain and range, restrict my domain and range for the inverse function. All right, true or false questions. Again, when I typically ask these, you don't really have to do a lot of work, but obviously we have to do some explanation here. So the first one, the square root of x squared plus 16, is that equal to x plus 4? Let me start off right away saying that that is false. One way to prove that it's false is to basically throw in a value. Don't use 0 because that's the one that's true. If we tried something like 3, right, 3 squared over here would give us the square root of 25, which is 5. But over here, 3 plus 4 is 7. So when x is equal to 3, this is no longer a true statement. And so once I find one that doesn't work, that means we're not a true statement at all. It's not just enough to find one. The other thing that we have here is the classic situation that when you're taking a power of a sum, it's not equal to the distribution of that power over the terms. Please get out of that habit. It comes up a lot in our trig class, and you're going to get a lot of things wrong if you do that. So here's my first stab at letting you guys know that you can't take the square root of each piece. The square root doesn't break up over a sum. You got to treat it as one entire entity. If f of negative x is equal to negative f of x for all x in the domain, then f of x is an odd function. This is actually a true statement, all right, because to be an odd function, all right, let me graph an odd function here. The picture down here has to be the same as the picture up there. We're basically symmetric with the origin, but what I'm saying is, you know, here's x and here is negative x, and you'll notice that the function value up here is the negation of the function value down here. So it's basically a double negative. If I replace x with negative x, then my output gets replaced with negative f of x, and that's all that's saying there. So if my input is replaced with an opposite, then my output becomes an opposite, and that's what we can kind of see in an odd function. Otherwise, a nice way to describe it is symmetric with the origin, which that is. A zero of the function f of x equals x cubed plus 8 is the number x equals negative 2. Well, to be a zero, that means when I plug the value in, we get a 0. So essentially, all I got to do is plug that into the function. Negative 2 cubed is negative 8. Negative 8 plus 8 is 0. So this is also true. It satisfies what it means to be a zero of a function. You put it in, you get 0 as an output. The function x squared minus 1 over x squared plus x will have a hole in the graph at x equals negative 1. All right, so to get a hole in the graph, that basically means that negative 1 makes the top and the bottom equal to 0 at the same time. Or what you can do is basically factor, right, x plus 1 out of the top and the bottom. So if we factor the top, we get x minus 1, x plus 1. And if we factor the bottom, we get x times x plus 1. So notice that if we let x equal to negative 1, that'll be 0 and that'll be a 0, but they do divide out, giving us the simplified form of x minus 1 over x. So now the function is defined despite the fact that it was undefined at the beginning. That's a classic condition for a hole in my graph. All right, and so the answer to this one is true. All right, if f of x is equal to x plus 3, then the inverse function is 1 over x plus 3. All right, this right away is false. This f to the negative 1 doesn't mean that we are, you know, if I have 5 to the negative 1, that does mean 1/5, that we're kind of putting something on its head or doing a reciprocal. But f is not a number, right? F is a function name. So it's designating the inverse function. And so no, as a matter of fact, if we wanted the inverse function, we'd have to go through what we just went through. That should be an x. Subtracting 3, the inverse function is actually x minus 3, not 1 over x plus 3. So that's false. So be careful about how you read that negative 1. If it's applied to a number, then it is a reciprocal. But it's applied to a function, then we're invoking an inverse function, which is a lot more complicated. Okay, I think I have time. Let me go ahead and do number 6. All right, so number 6, we're given a function 2/3 x plus 4, and we're given a function 3/2 x minus 4, and we're asked to find that composition. Well, that basically means that we're finding f of g of x, which means we're putting the g function into the f function. So it looks like this now. So we're putting 3/2 x minus 4, we're putting it into that function. So when we do that, we get 2/3 3/2 x plus 4. All right, so that's all it's asking. Oops, 3/2 x minus 4 plus 4. I kind of got, all right, so we're replacing that x with g of x. I'm sorry, I messed up my signs. So if we now do a distribution, right, if we now do a distribution, right, 2/3 times 3/2 is 1, but 2/3 times 4/3 is 8/3, and then plus 4. And getting a common denominator, right, this would be 3/3. You get x minus 8/3 plus 12/3. It looks like we get x plus 4/3. So there would be what that composition is equal to. So if I compose this line with that line, what we end up with is that line. Okay, so we're 10 minutes into this video. That's a lot of information, a lot of review. How about I stop there and cut away to a new video and start fresh?